So I know digital platforms and platform thinking and all of these are the new good buzzwords in our industry. And if you ask anyone, they'll say, yes, we are building platform. Yes, we are working on the platform and all of that, right? And that's the thing that is there in the industry as well, that you need to have platform thinking while building your applications as well, right? And that's where we came up with, we have been doing this for long. How many of you are using engineering or building engineering platform, or this is also known as developer platform or internal developer platform in your organization? Have you heard of what is developer platform or engineering platform? Few folks. Okay. So let's demystify that first. So what is engineering platform or internal developer platforms is, it empowers the product team to build software which eventually helps the business. Faster time to market, better business agility, all of that. So this is like enabling the developers to do their job, correct? In simple words, help developers to do their job and it will help to deliver faster. That's the fundamental of the whole engineering platform or the developer platform. Now what are the key components of that? We talk about three key components. The first one is the delivery infrastructure hub. Now this is the classical infrastructure provisioning part of it, CI/CD, observability, all of that. So whenever we need to set up any application, we need infrastructure, databases, we need CI/CD pipelines, we need observability for that. All of these are as part of the infrastructure is needed, right, for deploying any application. So that's your first part of the engineering platform. So you take care of all that need in this pillar. The second pillar is the service hub. None of the application can coexist without any other talking to any other application, right? So even in your ecosystem, in your organization, you will realize that application A wants to talk to application B. There are many such interactions that happens. Most of the energy, most of the time that we spend is in the integration, right? We need to take the API documentation, test, validate, integrate, and then connect, I mean, it's like deploy to the further downstream environments. So this service hub is all about APIs, events, and data across different applications. The third part is about the knowledge hub. Whatever we have built so far in the organization, people coming, going out, we need to have put together into some place where we can collaborate, where we can share with each other. It's knowledge sharing space as well, and we can have the troubleshooting guides, we can reach out to other application teams and all of that, right? So these are the three key pillars of the engineering platform. On top of this, there should be a good governance where we talk about real-time dashboards and metrics around this whole structure that we have put in, right? What I mean by that is, how am I doing with my CI/CD? How many times it is running, what kind of builds are breaking, what is the trend, all of that needs to be visible, right? We say that how is my code quality, that should be also visible. So all of that comes into the governance pillar. And then putting all of this in the whole organization is a mix of many applications, and all these are fragmented. Like I'm using for CI/CD GitHub Action, I'm using cloud deployment AWS, I'm using provisioning, I'm using Terraform. So all of these are different fragmented systems, right? We need to bring them together under one roof, and that's why we call it as a developer experience portal. So this is the place where developer can go, they can look at what are the API documentation, they can ask for creating new project where the repositories and everything is created by itself, and they have all these sensible defaults, best practices documented in a knowledge hub as well, right? So they're putting all this together in a developer portal. The classical example of this is Backstage. Now this in nutshell is the overall engineering platform. In short, engineering platform makes life easy for developers. That's the key part of it, right? Now, if we have to build this platform, what are the steps? The first step, in the organization, we should have a good technology strategy defined, which means that we are using Java for most of the application, that's our default. We are using AWS or GCP, that's our default, so that everybody is aware that this is the strategy of the organization. And every organization have their own reason, whys and all that for choosing the appropriate technology for their organization. Second part is to have the engineering practices, SOPs, and we call this as sensible defaults defined for that, which means that for Java, the Spring Boot is the default framework. There are n number of others, but this is the sensible default. So if your application can use that, done, we are good for it, right? So that's how you set up the second part of it. And then third is again bringing all this under one portal, which is your developer experience portal, where you have all this as a self-service capability. Now this all sounds good. Yes, we all want this, correct? This will make life easy for all of us. But where we are, what we have to do, that's where the challenge is in implementing the engineering platform. Challenging is not visualizing. You will find a lot of places that this is a vision. Yes, we want to build this. But how to do? First part, we don't know what is the current state of the organization in all of this. Where we stand. What we already have is the first question that comes in our mind. Second question that comes in our mind is, we don't know where to start, or we don't know how to move forward in this journey of building engineering platform for my organization. Third, okay, if I build, I'm not sure I'll have a good adoption. I don't know, there'll be a resistance in the organization when I start building this. All of this will start kicking in. And the fourth is, how do I measure success of this platform? What will help to measure how good platform we are building? So it is important to have the success measures as well. So all of these are the classical challenges or the problems that we see and we have seen while working with many clients, many organizations that struggling in this space. They all know that they need engineering platform or IDP for their organization, but they don't have answer for this. And this is where over the years we have come up with our own framework and the model.
All right. So how do we solve these challenges, right? We understood what an engineering platform is, how to build an engineering platform, and what are the core challenges when we try to build this platform, right? How many of you have worked with AWS before or in AWS? Most of you, right? So whenever we build systems or any application in AWS, we have a framework which we call it as AWS well-architected framework, right? So using that, you should be able to assess your system or the applications which you have built in AWS, right? So similarly, we need a framework to assess the engineering platform as well, right? So that is where this capability maturity model comes into a picture, right? So let's understand what this capability maturity model is. So it is a framework to assess the current capabilities in a structured way, all right? So an engineering platform will have a lot of core capabilities, and if you want to assess each of those capabilities, this framework is very useful for that. Once we assess the platform, what we end up doing, right? We end up identifying what are the gaps and areas of improvements are in my platform, right? Once we identify those, the next ideal plan is to create a roadmap to address those issues, right? And eventually make a decision that in a platform where I should be investing next, right? So with the help of this, you should be able to craft your roadmap and work on it. And once the platform starts getting evolved, you can then communicate about your platform capabilities to all your consumers and align all the teams about it, right? So this is what a capability maturity model is, and it can be used as a framework to assess your engineering platform, all right? So now let's understand what are the key elements of a capability maturity models, okay? So the first one is maturity levels. So these are nothing but progressive stages which starts from an initial ad hoc stage and it goes up to a fully optimized stage which is more aligned to your organization business, all right? And each of this maturity level will have some characteristics pertaining to that particular stage, okay? Next key element is capabilities, right? As Sunit had mentioned that in a developer portal, you can have some core functionalities, right? You could have a knowledge hub, you could have a services hub, you could have a delivery infrastructure hub, right? So all of this forms your core capabilities or core functionalities of the platform, all right? Next is best practices, all right? Best practices define for each of my maturity level, what are the business and operational practices I should be implementing. What this is going to help the teams is to identify what is the current state of my platform is, and if I want to take this platform to the next matured level, what are those best practices I will have to implement, okay? And the last is success measures, right? When we work on industry, we need to have some measurable indicators, right? Based upon which we can actually say whether we are making a successful progress or not, right? So these forms key elements of our capability maturity model. Now let's understand what are those different maturity levels are, right? First one is novice, where we are always reinventing, right? For any situation, for any problem, without even understanding whether that problem has been already solved within our organization, we are always trying to reinvent the wheel, okay? You see the problem, right? Like a lot of energy goes into solving the same set of problem in this level, right? So how to go to the next level from here, right? Which we call it as an exploring maturity level, all right? So in this stage, the main characteristic is people dependent, right? Here, there is a lot of collaboration and communication happen between the teams. So instead of reinventing the wheel all the time for any new problem, we end up talking to other people if they have already solved this problem before, right? So we try to rely a lot on the previous knowledge in the organization, but which is a bit more on a people, so we have a dependency on the people on it, right? Again here, there is a lot of challenges, right? So next stage is building, right? Where now we have identified the common patterns, right? What are the common problems, common issues all the application teams are facing, and then probably addressing those repeatable pattern by maybe forming a centralized team, right? And then helping to solve all those problems for all those application teams, right? Next one is optimizing. So in building stage, most of these repeatable patterns might be getting solved in a manual fashion, right? So again, manual, if you have a lot of manual intervention, then you end up running into a lot of challenges, right? So how to solve those problems? By going to the next level, which is optimizing, where we focus a lot on automation. And the last maturity level, we call it as a strengthening, where everything has been published as a self-service capabilities to the application team. So I'll take one example of one of the capability and I'll walk you through the maturity level. That way you should be able to relate to that more, all right? But before I do that, let's understand what are some of the core capabilities an engineering platform should ideally have, all right? These are some of the core capabilities we think an engineering platform should have. As you can see, we have delivery infrastructure, observability, CI/CD, DevSecOps, integration hubs, and all of these can be subdivided into multiple subcategories or sub-capabilities as well. For example, observability, right? Observability can have multiple sub-capabilities, like we could have monitoring, alerting, right? Even for delivery infrastructure, right? When I'll take an example of that, you should be able to understand that when we talk about delivery infrastructure, there are a lot of different caveats to that and a lot of different facets to that. So that even that can be sub-categorized into multiple different sub-capabilities, okay? So I will take an example of a delivery infrastructure capability and let's understand how the maturity model for that capability would look like, okay? Let's assume that Sunit is a part of one application team and he wants to provision an RDS database for his application. Okay, he might be maybe he wants to create that database in AWS. He might be able to. Okay, before actually going to a provisioning stage, he might be thinking about how should I create this database, right? Should I directly go ahead and make use of the managed RDS service? Or should I create a self-managed database on EC2 instances, right? So even before provisioning a database, Sunit will have to make a lot of decisions, right? And assume that along with Sunit, there are other people in a different application teams. They also needs a RDS database, right? So in Novi stage, all the teams are creating that databases in their own fashion. So that is where we say that the capability level for this delivery infrastructure is at Novice. Like it is very ad hoc, okay? So you understood the problem here, right? Everybody is branching out, they are doing their own way, in their own way. So how to optimize this further, right? So the next stage is exploring, right? Now let's say I want to create an RDS database for my application team. Somehow I got to know, okay, Sunit has provisioned an RDS database, let's say last month. I will go and talk to Sunit. Hey Sunit, how did you create an RDS database in AWS? I also want to create that. Can you tell me, right? So you see, now I have introduced a people dependency over here, right? So Sunit should be able to help me out. He might be able to maybe share those manual steps in a Word document over an email to me. I should be able to get the database created with the help of that. But you see an issue here. Let's say 2 months down the road, I want to do some updates. Now again, I will have to rely on Sunit and understand how I will have to update this database, right? So in this stage, it is a lot of people dependency over here because we are using the previous setup that has been used by our people in the same organization. So how to optimize this and go to the next stage? Building, right? Now let's assume that like Sunit and me, there are 10 other people in 10 different application teams who wanted to create the same RDS database, right? We identified what are the common repeatable patterns are, and we as an organization decide to create one central team who will have all those provisioning steps with them, and they will help the application teams to get those RDS databases created for them, okay? So that is what we call as a building stage, okay? But in building stage, that central team is provisioning all these databases manually, okay? There is no automation. So how to optimize that? By actually introducing an automation. We could even introduce a ticketing based system as well. For example, ServiceNow, right? So all the application teams should be able to submit their RDS database provisioning request through that ServiceNow portal, and the central team, with the help of that automation, will get that databases created for all the application teams. But do you see any challenges here, right? The lead time to get that database provisioned is again increases. Since we have a ticketing based service, there are going to be approvals that will be needed, right? And if the number of provisioning requests starts getting increased, right, the central team will become a bottleneck, right? So how we can ensure that central team should not become a bottleneck, and the lead time to get my infrastructure provision for my application team should be increased, right? So that is where we evolve into the fully optimized strengthening state, where all this automation which central team has now created, we are going to publish that in a self-served manner to all the application team. So that central team now has actually become a platform team who has created a platform where they can list all the services application teams can get provision. They can even bake sensible defaults in all those infrastructure products. They can have security baked into that. And of course, for automation, I forgot to mention that, they can even create IAC modules for that. For example, Terraform, right? They can write Terraform modules to provision RDS databases, to provision Kubernetes clusters, to provision data services in AWS. I'm just taking an example of AWS, but this can be done in any infrastructure ecosystem, right? So this is where the beauty of this capability maturity model are, right? It talks about what are the different maturity levels we could define. If you define what should be the capabilities of the engineering platform are, and then you can basically chart all those capabilities against this maturity model and define what are these best practices are for each of those model, right? So now let's see how you can actually craft your journey using this maturity model. Okay, when I introduce this model, I talked about these 4 key points, right? Assess, identify, create, and communicate, right? Let's take the same example of delivery infrastructure capability. Now let's assume that I have built an engineering platform which has this delivery infrastructure capability, and with the help of that, application teams are able to get the RDS database provision, right? But currently what I felt that I have a central team, they are able to get those databases created, but they are doing that in a manual fashion. So I am going to assess that for delivery infrastructure capability, my platform currently stands at building level. So my current state of the platform with respect to this particular delivery infrastructure capability is at a building stage, all right. Now I am going to identify what are the gaps and areas of improvement are with respect to this capability, right. It's quite easy to get that information from this model, right. If I want to go to the strengthening, I will have to first go from building to optimizing level, right. So I will have to introduce some automation, introduce some ticketing systems, right. And once I reach to the optimizing state, I can start creating a roadmap to go to the strengthening state, right. So that is what we call, once you identify areas of improvement, you can create a roadmap and define where I want to invest next when it comes to the engineering platform and different capabilities, right. And of course, once you reach to the strengthening state, or if you go from one stage to another, you can communicate that across your application teams, right, that hey, this is something we have introduced in our platform and you should be able to make use of that, right. So this is how you should be able to craft your journey. And we have, yeah, go ahead, sir.
Here there is a chance that within the organization, we don't have just one database, right? There are multiple flavors of it being used. So you start your journey by choosing what is the most used database. It could be Oracle for the surprise, not the Postgres one. And that's the reality of the organization, and you have to provision that. So automate that first. Get that to the level where people can start leveraging and adopting the automated scripts and self-provisioning if needed to be. Then you have a second step to it. Okay, now next most used database is MongoDB, for example. Do that in your journey. So that's how you create your action plans, and then you communicate that to the organization, which is important here again, right? That okay, I have assessed my current infrastructure, I have identified what are the gaps that I have created a plan that how I am going to address, and I am communicating it to the organization. All these are important when you are building platform, because for a platform building, the customers are internal developers. We need to make sure that they are part of it and you take the data from them. It cannot happen in the isolation. So all the capabilities, list down all the capabilities, sub capabilities. For each of the capability, think about where you are in the journey, where your organization is, what are the different flavors within the capability is also important, right? The capability is simple, that everybody needs a data store or a database, but their flavors are different. Same way, if you look at CI/CD, some team might be using GitHub Action, some team might be using Jenkins. Then you have to address both. You can't say we will not do this or that. Then your adoption is not good, or you are not building something for the platform. When we are doing all of these for a single project, it is not a platform. You are just doing for your own project, that's all. But within the organization, there are around 200, 500 applications. That needs to be catered when we are looking at the platform.
Yeah, and just to add to what Sunit mentioned, right? We don't have to really focus on tools and technology, right? We need to move away from that and think more about capabilities and outcomes. If you have heard Dr. Venkat's keynote, right, he talked about don't be like a fast horse, right? You don't have to have a fast programmer or a developers in your team, right? If you have to talk about platforms, right, you don't have to think about based upon only tool and technology, how fast I should be able to integrate those, right? Instead, you should be focusing more on what capabilities I could integrate in this platform and what outcome it will help me to achieve, right? At the end of the day, as Sunit mentioned, right, internal application teams are the main consumers of this platform, right? So we have to think from their perspective as well, okay? And I'm happy to share that for few engagements, we have helped our clients with their platforms, and we have introduced this capability maturity model, and we have used this as a structured framework to transform and evolve their platform. Anything you want to add on that, Sunit?
No, I think good.
Okay, cool. So next is success measures.
So now we understood the overall platform. We understood what its capability maturity model is, how it looks like, how to use it, how to craft the journey and all of that. But we need to understand what are the good success measures for the engineering platform. Now success measures can always tied back to the eventual business outcome, which can be the business agility, time to market, but those will come at the later stage, right? They are called lagging indicators, right? That will come when it happens. You need some of the leading indicators as well when you are building your platform. So few of them are here. So KPIs are like adoption is the key. Developers needs to come and use this platform every day. Then your engineering platform is successful. Otherwise, it's just a vision that I showed it to my management, everybody is happy, but developers are not using it. Then it's of no use. It's like customer centric approach, right? So you have to see the platform adoption. Second is the how many percentage of capabilities are reach the level of self-service. You can think it like a simple thing like creating a Kafka topic can be made a self-service capability, right? So that people don't have to wait for someone to create a Kafka topic. Oh, today I raise the ticket, tomorrow somebody will look at it, day after tomorrow somebody will approve it. After that, जब मन में आएगा तब वो कोई एक इंजीनियर उस पर काम करेगा और एक टॉपिक बनेगा. So that's the journey that we have seen. But we have come from the world of AWS and GCP. We have to apply those learning in our day-to-day building or whatever we are doing as well, right? So that's where start measuring how many are still pending, right? How much percentage of capabilities have reached the stage of self-service, which means that a development team or application team or the product team can themselves fulfill their own requirement, right? The third is which eventually reduce the cycle time for the developer, right? Example of creating a Kafka topic. How many of you have raised the ticket or sent the email to someone and waited for days to create a Kafka topic, right? How many days? Few days. Now this, if you have automated, how much time it has to wait? Few minutes maybe maximum. You just raise a topic, doesn't have to be that much rocket science where you are not incurring cost, you are not adding nodes or servers and all of that, right? Where you might need approval. And then eventually it will reduce the cost. If your cycle time is reduced, so see if your cost is reducing also or not. Because then it's a real value, right? Or an outcome that we have achieved. So your cost of operation cost, your cloud cost, all of that should reduce further. That's the key KPIs that we suggest to measure while measuring the success of the platform. And the key takeaways is, remember you can't improve what you don't measure. Intuition is not enough. A structure model provides clarity. So you need a structure approach when you want to assess your engineering platform or the developer platform that you have built. Focus on capabilities, not on tools. Well, we'll say, oh, we have to automate Kafka. No, messaging is the key, right? Or example of databases, right? provisioning of databases is key. Identify how many databases you have in the organization, assess them and all of that. Aim for incremental progress. Don't try to go from novice to direct strengthening stage, right? Because you need to learn and have your own journey. And craft realistic course or a path for your engineering platform building. So go step by step, have your journey, something you will be able to achieve faster, go jump steps and all of that, but create that action plan and communicate the action plan, which is very important.